Students, welcome to the video. In this video, we will be discussing the second topic, that is screen chambers. Screen chambers. Screening is the unit operation in the wastewater treatment plants. As already we have discussed about the screen chamber, that screen chamber is used for removal of the floating matters present in the wastewater. A screen is device with the openings, generally of uniform size, used to retain a suspended or a floating coarse materials like pieces of clothes, wood, leaves, plastic, rags, papers, etc. found in the influent wastewater. These materials must be removed at the beginning of the treatment process, otherwise could damage the subsequent process equipments, example pump, valves, pipeline, impellers, thereby reducing overall treatment process reliability and effectiveness. So here you can see the picture of the screen chamber. Here the screen is provided at an angle between 30 degree to 60 degree to provide a maximum surface area for the removal of floating matter. Objective of the screening: to reduce the load on the subsequent treatment units, to reduce the damage to the pump, and to protect the valve and the gates to ensure the better operation. And the third is to remove any bulky and unsightly floating matter carried in the sewage, raw sewage. Now, what are the features of the screening? The screening element may consist of the following. First, parallel bar or rods, gratings, wire meshes and perforated plates. So, in any form you can provide the screen. It may be a parallel bars or the rods or the grating. It may be a wire mesh also, or the perforated plates, means the plate with the holes. The opening are usually rectangular or the circular. However, could be of any shape. Depending on the size of the opening, the screens may be coarse, medium or fine. So let us have the discussion over the different types of screens. First of all, the coarse screen. Coarse screen have a clear opening ranging from 6 to 150 mm. Coarse screen consists of parallel bars, rods or wires. As we have discussed, it may be a wire mesh or the perforated plates with the opening generally of circular or rectangular shape. So please keep in mind, the opening should be only of the of shape circular or the rectangular. It is also called as a bar rack and used to remove coarse solid such as rags and large objects that may be clog or cause damage to the appurtenances. Based on the wastewater screening method used to clean them, coarse screen is classified into two types. The first one is hand cleaned coarse screen and second one is mechanically cleaned screen. So let us discuss the hand cleaned coarse screen. This type of screen is used in the screening process in the wastewater treatment at small facilities. Hand cleaned coarse screen are hand racked. They are ideal to use as a standby during the period of high flow or when more modern mechanical screening methods are under repair or maintenance. So when the maintenance or the repair is carried out for the mechanical screening, such type of hand clean coarse screen can be used for a certain period. Whereas the mechanically clean coarse screen increases the efficiency and reduces the problem in the wastewater treatment processes. Second one is fine screen. Fine screens are mechanically cleaned devices using perforated plates, woven wire cloth or closely spaced bar with clear opening of typically less than 6 mm size. Fine screen are generally used for pre-treatment of the industrial waste to remove the material which tends to produce excessive scum or foam. Fine screen are not normally suitable for the sewage because of the clogging possibilities. Fine screen may be of the drum or the disc type, mechanically clean and continuously operated. Now, what is the hydraulics behind the screen? The screens are provided to remove the material which would impede the flow in the treatment plant. Hence, continuous cleaning arrangement can keep the interference of the solid material to the minimum. So, it is very necessary that the floating material should get removed so that the entire treatment process will flow or will carried out smoothly, and there will be no interference due to such type of solid materials. On the other hand, the periodical cleaning arrangement may cause a surges of high flow after cleaning. Now, it is also an important parameter that once the screen get clogged, it should be cleaned periodically. But after cleaning, as all the pores or all the holes get opened, there may be chances of surge of high flow after the cleaning. So, ekdam sudden, there will be sudden or the high current of the wastewater which may occur. Usually, the base of the screen is placed a few centimeters below the invert of the base channel, and the grade of the influent conduit is steepened immediately preceding the screen. Velocity through the screen. Velocity through the screen should be such that the maximum amount of screening, preferably 100%, are retained without undue deposition. So, velocity, we have to maintain the velocity such that 100% material will get removed or will get retained on the screens. Velocity of 0.6 to 1.2 meter per second through the open area of peak flow have been used satisfactorily. So, usually 0.6 to 1 meter per second velocities are desirable and can cause a sufficient deposition. The velocity should not be less than 0.3 meters per second to prevent the deposition of solids. A velocity of 0.8 meter per second is appropriate for the considerable amount of storm water while preventing a great deposition at the bottom of the screening. So, from this it is clear that it should not be a velocity through the screen should not be a too high, so that it will cause the flow of entire material through the screen, or it should not be a too less, so that it will cause the deposition of the solids. So, the appropriate and the desirable velocity is 0.8 meter per second. So, with this velocity, it will prevent the grit deposition at the bottom of the screen. A straight channel succeeding the screen assures the good velocity distribution across the screen and maximum effectiveness of the devices. Head loss through the screen. Head loss depends on the quantity and the nature of the screening accumulated. Head loss can be calculated using this formula, where h is the head loss in the meters, v is the velocity through the screen in the meters per second, and the small v is the velocity before the screen in the meter per second. The value of h is usually 0.515 meter and should not exceed 0.3 meter for clogged hand screen. Second is the head loss through the screen. Another approach to determine the head loss through a bar rack is by Kishmer's equation. It states that h is equal to 6 into beta in bracket w divided by b raised to 4 by 3 plus hv into sin v, where h is the head loss in the meter, beta is the bar shape factor, w is the maximum width of the bar facing the flow in the meter, b is the minimum clear spacing between the bars in meter, hv the velocity head of the flow approaching the rack in the meter is calculated as h suffix v is equal to v square by 2g, and the theta is the angle of inclination of the rack with the horizontal. There are typical shape values for the different types of material. Sharp edge rectangular bars are having b value 2.42. For rectangular bar with semicircular upstream is having value 1.83. For circular it is 1.79, and for the rectangular bar with both upstream and downstream face as a semicircular 1.67. So here you can observe that for the sharp edge the B value is more, whereas for the circular edges or the for blunt edges or the surfaces the B value is lesser. Then once the wastewater, once the screening is being carried out, the screen or the material deposited on the screen, it should be disposed of very safely. The quantity of screening varies depending on the type of screen as well as sewer system and its characteristics. Quantity of screening removed by the bar screen mostly ranges between 0.003 meter 35 to 0.0375 meter cube per or 1000 meter cube of wastewater treated, with an approximate typical value of 0.015 meter cube per 1000 meter cube of wastewater. Screening is usually disposed of along with the municipal solid waste on sanitary landfill. It can also be brought back to the wastewater after passing it through the grinder or disintegrated pump. Other options include incineration. So the deposited screening material can be incinerated. It is nothing but the burning at a high temperature or the burning at a plant site for the smaller plant. So in this video we have discussed about the screen chamber, its type, different types of the screens, its hydraulics behind the screening, head loss through the screen and the disposal of the screen. Thank you for watching.